In the fourth video, we are going to create our first script that will place the character in a random position. In the process, we will see the tags and how to use the elements of the hierarchy in a script. It's important to keep in mind that this video is not about studying syntax or programming. The script can be downloaded from the link in the description, or you can pause the video to copy it. Now let's get started. We begin with the following scene. We have 4 gates arranged as follows. The idea is that when the game starts, the character appears randomly in front of one of them. Let's start by creating an empty object and give it the name spawn point. Set an icon to be able to see its location more easily. Let's define a tag for this object. Click on the drop-down menu Tag and then Add Tag. With the plus sign, we create a new tag and give it the name spawn point. We select the object in the hierarchy and assign it the tag we just created. Now go to the scripts folder, right-click, create, C# script. We write the name game control without spaces and differentiating the words with first caps. This notation is known as camel case, and we are going to use it very often. Before opening the script, go to the Edit tab and click on Preferences. Inside External Tools, we are going to check that we have selected a script editor. In my case, I'm going to use MonoDevelop. Now, double-click on the script to open it and we start writing. Square brackets, serialized fields, private string, tag. With this line, we have just defined a text type variable. For this script to work, we need at least one of the objects in the hierarchy to have it among its components. I'm going to create an empty object and call it control. I take the script and drag it to the Object Inspector tab. You can also achieve this by using the Add Component button. This little circle in the script tab means that there are unsaved changes, so press Ctrl S. Now we can edit the tag variable in the inspector. Let's give it the same name as the tag we created before. It's important to keep the caps in place. We define a game object that will save the character's prefab. Go to the prefabs folder, character, and drag the prefab to the game object space in the inspector. If necessary, the inspector can be locked with the pet lock at the top right. Let's define another game object to save the instance of the character. In this case, we skip the serialized field instruction. Define an array of game objects for all the spawn points and go to the inspector to observe the changes. We see that the game objects array appeared, but not player. This is because we didn't write the serialized field instruction. We define one more game object for a randomly selected spawn point. Within the start method, we are going to write the following instruction. Spawn points equals GameObject.findGame. Here we see that 2 methods are suggested. The difference is that one returns a single object with a specified tag, and the other returns all the objects that have that tag. We keep this last one, and in brackets we indicate the tag. Let's remember, this tag was the designated tag for all the spawn points. When simulating, we see that the control object has actually found all the objects with the spawn point tag. If we make copies of the spawn point object and simulate again, we see that now the array contains more spawn points. We have managed to find from the script all the objects with the tag spawn point, and we have them organized in a vector, which means that now we can perform operation on this vector. Now I'm renaming the spawn points and placing them in front of the respective gates. The next step is to define a random integer. To do this, we use the Random.Range method and we put as arguments 0 and the size of the vector of spawn points. Random.Range excludes the upper value, so the random number will be between 0 and the size of the vector -1. With the following instruction, we choose one of the vector elements and assign it to the game object selected spawn point. When simulating, we see that in this case, point D has been selected. We stop and simulate again, and now point B was selected. The next thing is to make an instance of the prefab. We use the instantiate method and give it 3 parameters. The first is the prefab to instantiate, and the 2 remaining are the position and rotation that the object will have. These 2 parameters are taken from the chosen spawn point. Let's simulate the scene. We see that in the first case the character appears in point A, and in the second case in point B. We are going to organize these 4 instructions into a new method. This version here corresponds to the start method, and this one to the update method. Let's place our method below update. We declare the method, open and close the curly brackets, cut the 4 instructions that are in the start method, and place them within the new method. Now we just need to make a call from start. Finally, in the update method, which is executed once per frame, we will read the R key. When pressing it, the scene will be reloaded. To do this, we have to add a namespace. On line 4, we write the following. Using Unity Engine.scene management. This will allow us to execute the following static method. Inside the reading of the R key, we write the instruction scene manager.load scene and give it the parameter 0. We simulate to check that it works, and the last thing we are going to do is to fix the rotation of the spawn points. In this case, the character appears looking in the direction of the blue axis, so we adjust the rotation so that in all cases it appears with its back to the gate. We make a compilation and that's it.